Let us learn about literals. Literals are constant values that are used in a program. For example, here I have expression. Then in this, value 5 is used and 7 is used. This is a literal. And here a variable is declared and it is initialized with 25. So this is a literal. Now the next thing. See, we know very well that when we declare any variable, then we will mention its data type. It means that this variable can hold integer type values. It can hold integer type values. Like here in this example, I have taken it. So value can store integer type values. So variables will have data type. Then what is this 5 and 7 and this is 25? This is nothing but data. So will this also have type? Yes, literals will also have their type. They will also have their data type. So that is the important thing we are going to learn. So what about this 5 and 7? Which type of literals are these? These are values without decimal, integer values. So these are integer literals. These are integer literals. And what about this 25? And what about this 25? This is also a integer literal. Then let us look at this example. Here I have a double type of variable. To that, this literal is assigned. This is having a decimal point. So definitely it is not a integer. Then which type of literal it is? It is a double literal. It's a double literal. And the variable is also double. Now let us see the next example here. I have a formula, right? Area assigned 3.1425 into radius. So this is the formula, or this value is for pi. This formula is for finding area of a circle. Then what is this literal? What is this literal? See, any decimal value with a decimal point is by default a double literal. Oh, it means it is not float. No, this is not float. This is double. Any value with a decimal point is double. Any value without decimal point is integer. It's an integer. So this is default in Java. Then how about float and long and short? I will explain it afterwards. Let us look at these two also. Here I have a character. Character literals are enclosed in single quotes. They are enclosed in single quotes. And this is one more class available. This is not a primitive data type. This is a class and this is a reference and this is an object. We call it as object. And this object is actually a literal. Direct value is given in double quotes. So this is a string literal. So if you use double quotes, it's a string. If you use single quotes, it's a character. So I have shown you various type of literals. Now let us learn more about literals like float and byte or short. We will see it. See, here I have a table of all the data types in Java. These are all data types in Java. We have already seen it in one of the previous videos. So byte, short, int, long, float, double, char and boolean. These are all data types. Then if I have a literal, how to mention a literal as a byte type or short or int type? So for this, these three data types, int, short and byte together, int, short and byte, all these three together, they take integer literal. They take integer literal. Means if I have a byte b and I'm assigning some value, let us say 5, this is an integer literal, but the data type is byte. Yes, byte type of variables also take integer literal. And short type of variable also takes integer literal only. They also take integer literal. So it means there is no separate literal for short or byte. Yes, we don't have a literal of these type. We have a literal of type integer only. Okay, this is completed. Now let us move to next. Long. If I write any value, let us say 5 only, this is a integer literal. But to say that this is a long literal, I have to write L following that literal. Either capital L or a lowercase l, smaller l. Any L will do, like 5L. this is a long literal. So if you have any integer value followed by a letter L, then it is a long literal. Now move to next, float. If I have any value, let us say 2.5, as I said just now, by default it is double literal. By default it is double, it is not float. To call it as float, it should be followed by F, either uppercase or lowercase. So if you are writing F, then it means it is a float literal. And if you don't write anything, then it is a double literal. But for double, if at all you want to write something, you can write D here, either uppercase or lowercase D you can write, or even if you don't write it, it is by default double only. Then the character literals already I have shown you. Then lastly, Boolean. For Boolean data type, these are the literals predefined available in Java. True if you write, then this is a Boolean literal, or else you can write false. These are the two predefined literals. Only they can have values like true or false, any one of these. Now using a program, I will show you the types of integer literals, what are the ways of mentioning an integer literal for byte, short and int, all these. Then also I will give an example for other type of literals also. So let us look at it through a program. I have a skeleton of a Java program ready. I will first declare one variable here, byte b, and I will assign the value 15 to it. Then also I will display it, system.out.println b. So this variable is of type byte, but I am assigning it value that is 15. It is an integer value. Yes, it is allowed. I can assign integer value. This will print the value. Let us check it once. So javac literal.java, compile, java literal, cut off this class and run. Yes, it is printing. So similarly, if I have a short type of variable, then also I can assign a integer value. So same 15 I will assign. And for integer type value variable also, I can assign this one. So all these three data types accept integer values. They allow integer literals. Now the very important thing I am going to show you now. See, integer literals can be represented in various number systems like decimal number system or binary number system, octal or hexadecimal. If you are not aware of this, no problem. I'll explain a little bit. I'll give you sufficient idea about this one. Decimal number system will have digits 0, 1, 2, 3 to 9. A number is formed by using these digits 0 to 9. And binary number system will have only 2 digits. So any number is formed by using only 0 or 1. Octal number system will have 8 digits that are 1, 2, 3 up to 7. So I have written up to 7. So 0 to 7. We can form a number using only digits 0 to 7. If any digit outside this, if you are taking, it is not an octal number. If the digits are used from within 0 to 7 only, so it may be octal also, it may be decimal also, it can be any number. But if it is going outside 7, definitely it's not an octal number, it is a decimal number. And if you are using digits outside 0 or 1, then it is not a binary number. Now coming to hexadecimal. So this will have 16 digits. So digits are 0 to 9, I will write down first of all. 0 to 9, total 10 digits. Now it is having 16, so these are 10. Then it will have A, B, C, D, E and F. So these are 16 digits that are used in hexadecimal. So hexadecimal uses 16 digits, and octal uses 8, binary uses 2 and decimal uses 10. So usually we follow decimal number system. Even in our daily life, we write the numbers using decimal number system only. And in computers, other number systems are also allowed. So if I want to write any integer literal using any of these number system, yes, I can write it. So for example, if I take a byte type of variable and to that, if I assign value 10, then This is decimal number system, so I wrote just 10. Then if I want to write it in binary form, then I should write 0 B, then binary form of 10 is 1010. So yes, this will be a binary form of 10. So 10 will be stored in this B. Now same way, if I want it in octal form, then say B, just write 0. So I am writing it separately to show that it is not O, this is 0, and value is 12. So in octal number system, 12 is 10. Like here, up to 7 we got. So then 8 means 10, 9 means 11, then 10 means 12. So this is 12. Then if I want hexadecimal, then I should write 0, then X, either capital or uppercase, whichever case you want. And what is 10 here? A, write A, then this will be 10. So that's it. So integer literal can be represented in any of these number system. So I will write the program and show you for this one. So back to the program, I will remove this. Then I will declare byte B1 assign 10. This is a decimal, right? Then byte B2 assign 0B1010. This is 10. Then byte B3, this is 012, right? This is octal 10. Then this is B4, and this is 0x, and this is A, capital A. This is hexadecimal. Now I have already I have system.out.println, so I will say print B. Then also I will print all other values. So I will copy and paste this one. I am printing all the values. Let us save it and compile and run. It should print all 10s, right? Run the program. Yes, 10, 10, 10. All the values B1, B2, B3, B4, all these are 10, but they are in different number system. So I have shown it using byte. So it works on short and int and long also. You can use any of these number system. So that's all about integer literal. Now let us look at long literal. Now here I will declare a variable of type long, L assign 125, and I will print long. Will it work? See, I have taken a variable of type long. Literal is 125. Which literal it is? Integer literal. So can I assign integer literal to a long? Yes. Let us save, compile and run. Yes, it is working. I'll print it. Yes, it is accepting, it's working. Now come back. For calling it as long literal, I should write capital L or small l, anything, right? So I'll try to write some bigger number. I have given 12 digits number. Let us see. This is going beyond the size of integer. Yes, integer number too large. This is not an integer number. So let us make it as long, capital L. It's working. So now you can understand that if I am writing a literal, then it should be a valid integer literal. This number was bigger than the capacity of integer. We know integer take 4 bytes, so it is having its range. So I gave a number beyond its range. So this number is definitely a long type. Alright, then I'll show you one more thing here. I will take an integer type variable I, and in this I will assign 125, but I will write L beside this one. So it's a long literal, right? Long type of literal. Long type of literal cannot be assigned to integer type because this is larger and int is smaller. Let us check it. It's an error. Incompatible types, possible lossy conversion from long to int. So we got a similar error before also. So you can recall it. So the same thing, same error we are getting here also. So we can assign a literal to its compatible data type only. This cannot have long literal. That's it. Let us take it out. Now quickly we will see double and float. So float f assign 12.56, that's it. Then double d assign 12.56, number is same. Now here I will print float number, and then afterwards I will print double number also. Let us save it and compile and check. Compile. Oh, it's an error. I will clear the screen and do it once again. Now see it. Incompatible types, possible lossy conversion from double to float. So it is saying that this literal is double. That's what I told you. By default, any number in decimal form is a double, and we are trying to assign it to a float. So it's not allowed. By default, it is a double. So double is larger than float. So it's not allowed. So it is saying that possibly there is a loss of information. So for making it float, I should write F. Then here I said you should write D. Even if you don't write, it's okay. Let us check it. Now will it work or not? Yes, it works. Now one more interesting thing I will show you. Here I have an example of a long integer, and this is a very big number. So when you write a bigger figure on paper, then we use commas. Like here we separate it, so that's easy to read the number. So now we can make out there are total 9 digits. So if you want to give comma, here in Java commas are not allowed, but you can use underscores. You can use underscore like this. So if you have a bigger figure, then you can separate the digits by using underscore. Even it can be done in float also. So I have taken a small number here in float, so I will make it a little bigger. So I have 6 digits now, so I can use underscore here. So I will save and show you. This is compiled, executed. See, it's working. So it will not show underscore here in output, but that is only for improving readability of a program. So this is a very useful or powerful feature. See, one more thing that you have to take care. You are not allowed to write underscore after the end of a number, after the last digit. So it's meaningless. And here in float, you cannot use it after the last digit, even before the decimal or after the decimal. Here you are not allowed to use it here. I will save it and show you. See, it's giving error. This underscore is illegal. So you can read the error message, illegal underscore. And here also for this one, it is showing illegal underscore. So that's it. We have finished with the literals. So you practice this one. We have not yet started writing programs. We will be starting them in the next section. Don't just watch the videos. You start practicing Java.